Yes.
Now we can. Yes.
Yes, we can. Here, just the voice on laptop was too quiet. Nasty, I want to ask you to move to another room, okay? Maybe not mine, Nasty.
Do we have any plan who speaks well?
Now, okay, now it will be just easier because this time you will just talk about new native itself, lab and new native. I will start and then I will announce you, and then Cohere will talk about Cohere and challenge, so you don't need to jump when you talk about node.
Okay.
Hello, everyone, and I see that people in the chat already start rating. I'm so happy to see everybody here, and I welcome you to Semantic Search Hackathon powered by Cohere, our amazing partner. And I'm Alessia, and I will be happy to be your MC for today. Let me show the second slide. Yeah, I'm Alessia, and I'm a marketing manager at New Native and at lablab.ai, which is the host of this hackathon. And I'm really happy to be your MC for today. So today I will tell you a bit more of what will be during the hackathon, and also I will be able to help you during the event on Discord. So feel free to reach me out. Okay, well, today's schedule and schedule for whole hackathon as well. Now I'm starting with introduction. I will tell you a bit more about LabLab. It's the platform, about UNative, which is like father company of LabLab, and I will tell you about our amazing partner Cohere. We'll have also people from Cohere who will kindly tell us what's the company doing now, and maybe some new technologies, maybe some updates. So we will have this session when Cohere people will tell about the company, and you will be able to ask your questions in the chat as well. Then we will have introduction to the challenge. So yes, in this session, in 40 minutes, you will know what the challenge for this hackathon will be and what you need to work on. And I just forgot to mention that before the Cohere introduction, before Cohere opening session, we'll have Nasty, which is the community manager at LabLab, and she will tell you and make a little guide for you how to work with the platform and how to work with Discord. After that, at 7:45, we will have workshop about semantic search. So how to work with semantic search, what you need to know about semantic search. You will be able to ask all the questions you have during the workshop. And then we will have a lecture about multilingual semantic search, which is the newest model that Cohere just released, and you will be able to start building with it. It was released like 3 days ago, if I'm not mistaken, and today on this hackathon, you'll be already able to play with this technology, and we will have 2 amazing lectures, which is challenges and opportunities and tips and tricks about this model. Let's move on to the schedule for last days of the hackathon. Yes, fine. Okay. And I want to tell you that the previous hackathon was pretty packed with lectures during the week. This time we decided to make it only today, which is introduction stream, when you will know all the information you need to build during the hackathon. And as well, the last hackathon stream will be on Thursday, like the day before you need to submit your project. And we'll have also a very, very good stream that day, because we'll have interviews with our teams, with participants, which everybody loves. We'll ask you about your project ideas, like how the hackathon experience was for you. We'll have 2 hours of interviews with the best teams who wants to talk to us. After that, we'll have pitch workshop with Sandra from Cohere, and she will prepare you the day before you need to submit your project to this submission, and she will teach you practically how to make your project very attractive for judges and for people who will who will evaluate your project. After that, we will have closing session right before Christmas holidays, and in a day you will need to submit your project, which will be Friday midnight. And that's basically it. The hackathon should be really interesting, and you should be pretty engaged during the 7 days. We'll be happy to help you on the Discord during all this time. So it sounds to be really exciting. And let's move on to lablab.ai as a platform. Here in this call, we have Matthias Asberg, who is the co-founder of LabLab and UNative. And I will ask him to join me shortly, but now I want to start with LabLab itself to tell you briefly what the platform is about. At LabLab, we are a community of creators who are aimed to solve real problems using AI for this. So we provide you with access to the latest technologies. So you will be able to build your project with AI and to solve real existing problems. And I want to invite now Matthias. Matthias, please join us to the stage and tell us about LabLab and about New Native. Now I want to show Matthias for you guys. Matthias, are you here with us?
Sure. I also have yeah, yes. Simon is also here with me. He's also one of the co-founders. Okay. Are we on the stream now? Yes.
We are, yes.
Okay. Awesome. Yeah. So welcome everyone. I'm super thrilled to have you all here once again to build with us. I'm here together with Simon, that is also one of the co-founders behind New Native. With LabLab, we just want to create a platform basically where people come and build with technologies that we believe and many others also believe that are going to have a big impact on the ecosystem. So we pretty much trying to curate technologies that we believe have a really good value to start figuring out how to build with. Simon, maybe you can say some wise words.
Definitely. I think that the one of the most interesting problems that we're facing today is really to be able to access and to build on top of pre-existing things, right? And this stems true particularly for the generative AI space, which we're in, where it's, for one, it's super hard to just get access to the things that you want to build with. And even if you could get access, there's no real place, you know, to actually come together and build with your friends. So the starting point of LabLab was just that, you know, bringing cool people, bringing cool technology, and start to innovate together, build something that the world has never seen before, basically. And so we started doing that, and now, you know, we've seen so much uptake with so many amazing people, and parts of you are here on the stream today, listening in. And my wise words would basically be to just go out there and try to do as many or as much cool things as possible using the technology available, because in the end, that's sort of how we're pushing the envelope here and making this more available to even more people out there, whether that's, you know, through creating an app or whether it's creating, you know, just art in some cases as well. So I am very, very happy to welcome you to the hackathon, and I'm very much so looking forward to what you will create. It's always a super intriguing time when you give these short deadlines to see how far you can just come in a week time. So it'll be great to see where we end up with this hack. So I appreciate you dialing in.
Yeah, and I just want to finish with that. The technology you are building with this time is really cool in that way that there is a lot of really interesting applications to build using this type of technology stack, because basically what it allows is to make like anything searchable, like anything. And this is not really the case previously. So do you want to make an application that record all your voice memos and then being able to ask it any question about anything you said at any point of time and get that answer? Yes, you can do it with this stack of technology. And now recently with the new updates, it covers so many languages. So there's endless possibilities. So really think around it that way, and I'm sure great things will come out of this. Yeah, that's all from me. Thank you so much for.
Thank you so much. And remember, you're the pioneers of the space. So build something that's really dazzling us. It will be a joy to watch.
Thank you so much, Matthias and Simon, for introduction to LabLab and New Native. And I want to thank you again to our partner, which is Cohere, and it's easy to use large language models that allows you to speed up your process of building. To be able now you'll be able to build a much more cooler application using Cohere, and they aims to be the part of your toolkit. And I'm really happy for everybody here that you will be able now to learn how to build with Cohere and actually build your app using Cohere API. For this hackathon, it will open really a lot of possibilities for you, and you will just see after discovering. And a little bit more about Cohere will be next in the presentation, and I will move to the hackathon guide. When it comes to this hackathon, I want to just go shortly how you need, what you need to do to make this hackathon successful. First of all, you need to join the hackathon. Join the hackathon and then to connect the Discord on your lablab.ai profile. That's very important for communication. If you didn't connect the Discord yet, please go and do it right now. And after that, you need to join or create your team on lablab.ai platform. If you have an idea, and if you know which product you want to build, if you had just some idea in mind and you now thinking, is it possible at all to build, create your team. Create your team and promote your idea in Looking for a Team channel. And people who are interested in your idea and who are passionate about the field that you decided to build with as well as you are, they will also join you, and you may create a team together. If you just want to join somebody and help with building, join the existing team. And in the team page, you have just a short description about the projects, or if the project already have idea, you may choose whatever you like and join the team. After that, you need to meet your team on Discord or on chat directly on our lablab.ai platform. After that, when you meet your team, you have around a day or two to come up with your idea or 2 or 3 concepts. After coming up with the concept, you may contact the mentors. We have no specific timelines for contacting. You just need to tag mentors or use I need help button in your team profile. We'll talk more about how to use Discord and how to use our platform a bit later with Nasty. But now I just want to tell you that after when you understood few concepts that you want to work on, you need to contact mentors and discuss with them these ideas, and they will help you with choosing the best of the concept that can win this hackathon. After that, you have a lot of time, more than 5 days to build your prototype. And in the end of the hackathon, you need to submit your solution. And this submission is actually the aim of this hackathon. So in 7 days, you will be able to build the app that can solve some problems, and it will be your finished product that you did with AI during this week, which is very cool. Let's go for frequently asked questions section. I will help you a little bit understand how our platform works. And the most maybe confusing is how to create a team. We have really a lot of questions in the chat, like how can I create my team? And it's actually pretty easy. You need to go to your dashboard. When you register to the event, you have your dashboard at lablab.ai platform. And there you have the list of teams, and you have a button with create a team. So you may or create your new team, or go through the list and choose the team you want to join, the team that looking for members. Let's go to the second question, which is how to meet your team on Discord. So basically just use button connect the Discord on your lablab.ai account. And as I mentioned before, it's extremely important for communication with mentors and for communication with us as a team of organizers of the hackathon, because it will be really hard for us to communicate if we don't have any point of contact except of your email. Well, connect the Discord to have a really good communication and hackathon experience. Then communicate with mentors. Mentors are available through the whole event. We have a few types of mentors, which is the mentors from our side. It's like Nasty and me, so we can help you with questions that regarding the platform and Discord itself. Then we have technical mentors that can help you with your project or answer your technical questions. And we have business mentors that also can help you to choose the best performing idea and to help you with define your business model. So how to make money from the app that you will build during the 7 days. And for communicate with mentors, you need to use calling for a help button in your lablab.ai team page. Yes. And then I have amazing news for you because today we will have Nasty join our stream and she wants to make for you quick instructions how to use our lablab.ai platform and Discord based on all questions she had during last hackathons, and we had really a lot. And now she will join our stage to tell you and to guide you through all the communication, all the platforms we have here. Nasty, are you ready to join us? Nasty, I see that you are on the call. Fine. We can't hear you for some reasons. Please check your connection. Or we can do so. You may just join me here on the stream, and you can show it to people from here. Okay, now we can hear you. Fine.
Can you confirm, Melissa, can you see my screen on laptop.ai?
Let me check. Yes.
Okay, great. Hi everyone, my name is Nasty. I'm community manager at lablab.ai, and feel free to reach out me to get some help. So I will shortly introduce you our lablab.ai platform and Discord community. Hope you will have a great time with us. So once you are enrolled event, you will have a dashboard. First of all, I will show you that here you will find all details of Hackathon. Here you will find below our speakers, mentors, as well schedule. And also remember to check our tutorial page. And once you are enrolled, you will see here your dashboard page. And here you will have a button, create a new team, or also you may find the teams that are looking for members. So here you will go here, create a new team. And let's try to create some team. This. Okay. Yes, we are creating a new team, and remember guys that you need at least have 2 members with connected Discord to create a voice channel. So if you have idea to be a team leader, you have idea with team, so feel free to create new team, but remember to have a Discord channel, you have to have minimum 2 members. Okay, and then please connect your lablab.ai section, it's announcement section, and lablab general. Here you will write something. If you have some questions, feel free to ask us for help. And here also on section our team, you will find our mentors. for this hackathon, we will have Gonzalo. They will help you with any organizational or technical questions. And also feel free to tag me, Olesya, Laszlo, and Fabian. Then if you scroll a little bit down, you will find section welcome and introduce yourself channel. Here you may browse or you may write about yourself, about your background. And here we have happening now semantic search hackathon channel. So feel free also text in here, asking some questions. And below you will find looking for a team section, and we have here semantic search, treat for programmers and developers. So if you are looking for a team or you want to invite someone to your team, you can paste here link to your team and invite, for example, I need some technical guys and developers, or you can go here and find guys who are already developers. Yes, and here we have section with questions. So if you have some programming question, you may write there, I need help. Also general, if you have some problems, also you can text here. And AI general, it's questions about AI. Also feel free to tag us and to ask something. And the section knowledge, you will find different articles, AI news, videos, memes, especially my lovely section, my lovely channel. And here you will see it's my when you mentor calling for help, mentors will receive mentors will receive some notifications that, for example, team needs your help. So then why it's useful to use some calling for help button, because then we can hope we have an opportunity to notice your request and quickly jump to your channel and help. And you find you will connect your Discord, and if you will have invoice channel, you have here voice channel, and you will have a voice channel 1 and channel 2. When we have together interview, we will have like I invite you to open voice channel 1 and ask you be here.
Okay, Nasty, I see that the sound is like really, really bad and people don't hear us well. So I guess we can do the same, like repeat the same workshop before after all the lectures. Yes. Okay, fine. Let me continue then with my guide through the platform and through this hackathon. And now I want to tell about a very important part that we'll have. Please write in the chat if you can hear everybody of us good, because yes, so just for us to make sure that everything is going well. And Nasty will come back to you after all the lectures, don't worry. And okay, your presentation, it will happen on Friday, but you just need to know about it from now, so you will know, like you will have a structure how it should look like. And on your presentation, you should show us what you have built during this hackathon and to show us the demo of your product. For demo, we can advise you two platforms, which is Streamlit and Replit. Just briefly explain what does it mean. A demo of the project is like a website or page when we can go and play with your project during the evaluation process. So it's required to have a demo of your project to be nominated for being winner actually of the hackathon. After that, you need to show the process of building your prototype. What's your project structure, like for technical people to evaluate your project, how complex it is. And also very important for us to have a business plan. So how do you see your project perspectives? What do you see the business model of this project, how it can make money? So please make sure to put all of these very important moments in the presentation. And one more really important stuff that it should be no longer than 5 minutes. Because we will have really a lot of projects and our judges need to evaluate these projects and try to keep it no more than 5 minutes. Let's go next, and I want to show you the evaluation criteria for the project. Fine. Okay. The evaluation criteria, you basically see it now on the screen, so there is no big need to read it for you, but in general, we want to see very unique ideas that can solve the real existing problems, and it can be really highly applicable and have a huge business value. And for sure, it should be innovative and realistic to be to be built in general, because like technically it should be possibly to implement. It's super easy. And for sure, the overall impressions and the impact that you will make with your project is super important for us to evaluate. Okay, and now I have for you the information about prizes. Okay, I want to ask people probably on the call that they are ready to jump and help me with presentation. Please mute the sound because people on the stream can hear you. Thank you so much. And now, the most exciting part is prizes, and you already see it on the screen. And for winning team, for the team who will have first place, who will won this hackathon, you will have 5,000 of API credits for Cohere products and $1,000 cash. And also, as you may see, that 4,000 of API credits, as well as the cash prize, will be distributed among the finalists. Usually we have like one team who is winner in the hackathon and a few finalists. So it's very important to do your presentation really good so people can easily evaluate it, and you'll be able also to be a top team who will present your project during the winner announcement stream and to be able to be the best in doing this hackathon. And yes, additionally, the winning team will have a Cohere swag. That's just a good bonus. And now I want to invite our first speaker for today for Cohere opening, which is Nick Frost. Nick, please confirm that you are here on the call and you're ready to start the presentation. Okay, I will try again. Nick, are you in the call and are you ready to start the presentation? Well, I don't see the Nick. Okay. Yes. Yes, we can. Nice. Could you please turn on your camera and I will let people on the stage see you as well. Yes, we are live now.
Hey. Yeah, really happy to be here. Sadly, this Discord thing is not really working so well for me. So I wasn't really able to see anything before. But yeah, super happy that you're joining this this session on semantic search. As you know, I've been working quite a lot of time, like since 4 years, on semantic search, and it gives finally a search function that works so much better than than search before. So in most cases, search is really bad, works really poorly. So if you go on Wikipedia and you search for the capital of the United States, it returns your article about capital punishment. And everyone I talk to is totally frustrated with the search experience you get in your Word document, PDF document, email inbox. So anything that's not Google or Bing or Baidu is not really working well in terms of search. And semantic search makes search a lot better and also a lot easier. So now you can build like really powerful tools. Sadly, as mentioned, I have these technical difficulties, so I'm not really sure where are we right now in the agenda. Did Nick already kick off and give the introduction about Cohere? Did Lewis present already semantic search?
No, I have not.
I haven't either.
Great. So I think next one in line is Nick. I don't know. Are you on stage already? Can people already see Nick out there?
I'm here on Discord, which I think means it's good. But this is one of the, because we're on Discord but presenting elsewhere, correct? So it's hard to know.
Yeah, we're kind of, I don't know, watched before on Twitch.
Yep. Okay. Sweet. Well, hello, Twitch. I'm Nick. I'm one of the co-founders of Cohere. So yeah, very excited to be kicking off the search hackathon with you guys. We built some really cool stuff. Nils is typically understated, as always, but the model that him and his team have built for multilingual stuff is really amazing, and it solves a problem that I think like the world has faced for a long time, which is having a whole bunch of text in a whole bunch of different languages and not being able to search through it effectively. So at Cohere, we've been running this company now for about 3 years, and our whole like motivation is to try to take cutting edge natural language processing, which in this day and age turns out to be massive transformers, and put them into a form that actually makes them ready to solve real world problems. There's a huge gap between academia and between like what people in ML research are doing and between practitioners and like what problems actually need solving and what language models are the right ones for solving those problems. So we spend a bunch of time trying to make them easy to use, tailored to the right use cases. And one of the things we've landed on is multilingual search as a real like global problem that didn't have an easy solution. So now with these embeddings and with a language model that projects any language, or not any, sorry, 100 languages into the same embedding space, we think that really opens up the possibilities for doing all kinds of search across things at really like a global scale. So that's why I'm excited about this, because I think it represents like us taking our philosophy of trying to take language models and making them useful and tailored to real world applications. And this is like a really great example of us putting our money where our mouth is and releasing a model that does something that's cool and hasn't been done before. So we've done a few hackathons before, and the stuff that has come out has been like amazing. One of the most fun things about being a co-founder of a language modeling company is that I'm routinely surprised at what the people build with the tech we release. Like every time we do a hackathon, somebody comes up with something that I'm like, oh, holy shit, I've never seen that before. Like that's a totally new application of the tech. So that's really rewarding. So I'm really excited to see what you guys get out of this, what comes out of it. We've never done one with this model, so I'm particularly excited for that. But yeah, thank you all so much for being here. Like happy hacking. Good luck, and really excited to see what you guys come up with. Cool. That's kind of it for me.
Thank you so much. We're also very happy to have you on this hackathon, Nick, and really people build very cool stuff just with this technology, and we're also excited to see their submissions in the end of the hackathon. And before moving to the next speaker, I want to introduce to you Sandbox from Cohere, which is the collection of libraries with like pre-ready, I would say, apps that you can build with, and it makes your hacking, makes your building even easier with Cohere. So definitely for this hackathon, you will also be able to build with Sandbox, and which is the good news. So it will be even much more easier for you to start and to build really cool apps.
Things in the sandbox is a project I worked on. It's called Grounded QA. It's a thing for like answering questions based on factual information with language models, but part of that is a search component. And I recently swapped it over to the multilingual model, but haven't really explored what that means. So if anybody is looking for like something to kick off or like something to look at for an idea of what to build, taking a look at the grounded QA and the search component within that, and thinking about what's the fact that now we have a multilingual model means for that would be a great starting point. Sorry, just to plug my own project here, just because it's fun.
Thank you so much. Yeah, it's actually very good advice. People just take it into account to start building. And yeah, now to introduce into the challenge, I want to invite Niels for this time, and we already saw him in the stream today, and I'm inviting him like second time. Hi, Niels. Introduce yourself, please, and tell us what will be the challenge for this hackathon.
Great. Yeah, I think Nick already presented this very well. Search is like a key component. If you think about like knowledge workers, you spend so much time on searching stuff, finding information. And if you find the right information, it can give you like such a big advantage. Big challenge so far is the language barrier. Right now, you're limited to the languages you speak. But with machine translation, this was made a lot easier. So you can now well understand languages you're not speaking, for example, finding Chinese information. But still searching for this is like really hard. So is there like some super critical, important information in some other language that might have like a big impact on, for example, Apple and the quarterly earning of Apple? So will it maybe there's some great Chinese source on this talking about massive issues in the production of the iPhones, and you will totally know, okay, Apple will have like a really pretty bad quarter, and you can make millions out of this. Or is there somewhere in Arabic some information about the next big crypto coin that will skyrocket and will be like the next Dogecoin or so? And yeah, super happy to kick off this meeting on multilingual search. Louis, he will give a short presentation introduction to semantic search, what it is, and then I will follow up with some information on multilingual search, challenges in multilingual search, and yeah, then we're really looking forward to your creativity, how you're going to use it, and what type of cool applications you're going to build.
Thank you so much. Just to summarize, so as you may see on the slide, for this hackathon, you need to be as much creative as possible to build the coolest application you can using semantic search function, and this time as well multilingual text understanding model. And brief information about the technology and how you can actually find Cohere and start building. First of all this information you will receive with email that we'll send you after this kickoff stream. And but for let you know, during this kickoff, I will tell you that to start with this technology, you need to sign up on Cohere website, cohere.ai, and actually start building. Then you will see, you'll find the playground, and you may already start building with Cohere, building your apps on the website. And also for all help and for tutorials, you will use lablab.ai website. We have amazing page with tech tutorials about probably every model that you can find now, like on the internet, especially with Cohere. We have a lot of tutorials how to build apps with Cohere. You have even very detailed tutorials when you can already like start with your project. We have articles on our blog with ideas which apps you can build if you need some inspiration. So feel free to check lablab.ai tech tech section, and there you also will have a lot of support with tutorials. And also, you will have our tech help during the event because you have chats on Discord with tech questions. There you can also find very valuable information for you from our tech mentors. Let's move on to the next topic for today. And I want to invite to the stage Luis, who will tell and make for us general workshop what the semantic search is and how you can start with it. Luis, are you here on the call? Are you ready to start?
Hello, thank you very much. Yes,
Hi.
I'm here.
Well, now you are live.
Well, thank you. I'm very happy to be here. Thanks for organizing and happy to see all the hackers. Very excited to see all the creativity that's gonna come out in this hackathon. And so yes, I will share my screen over here. So do you see this presentation? All right. So yes, as you see the main slide, right? What is semantic search? Let's give it a second. In the meantime, I'll say yeah, as Niels said, I will be the opener for Niels. I will introduce sort of the very basic notions of semantic search, embeddings and stuff, and then he will elaborate on all the technology around it. So I'm checking if you see the slides or not yet. Stop streaming. Start streaming. Okay, go live. Is it working now? You can see it, right? Can you see the main screen then? Big title. Okay. Okay, what is semantic search? So let me tell you first, in very simple terms, what is not semantic search. So semantic search is lexical search, the one Niels was talking about when you say I asked for the capital of the United States and it tells you about capital punishment in the United States. So the one that was useful in the past, but it's not that great. So let's do this one. Let's say that I have a very small data set of 4 sentences. The World Cup is in Qatar, the sky is blue, the bear lives in the woods, and an apple is a fruit. And I have a query. My query is, where is the World Cup? And I want to see which one of those 4 sentences in my database is the one that answers that question. So lexical search is sort of word matching. And now let's consider everything a word. Obviously, you can do things to remove the word the and is and all that, but let's just do the most basic search we can imagine. So based on a number of overlaps, we have 4 for the first one, 2 for the second one, 2 and 1. So the winner here is this one. So that kind of works, but as you can imagine, this fails miserably pretty quickly. We have a different set of sentences. The World Cup is in Qatar. The cup is where you left it. Where in the world is my cup of coffee? And an apple is a fruit. Then this one, the one that wins is the third one because it has 5 words in common with the sentence, but it's actually not the answer. So we don't want, yes.
We can just see this first slide. What is semantic search?
Oh, really? Yikes. So we missed
didn't see
that.
any other slide.
Sorry
We
about
can
that.
see lexical search.
Can you see this stuff?
No, we see
No,
like
when
drawing board.
Oh, sorry.
Lewis, I think you should just click through the slides. You can just click through them instead of presenting. It seems when you click present, it looks like it goes to another screen. So
Okay. Well, I have a lot of transitions. So let me try one more thing. Okay, and if not, then I'll click through the slides.
oh, you made animations. How fancy.
I did. But you know, it's just it's okay if I click through the slides, but I think it's just gonna reveal all the all the surprises. Let me see. Let me try to just share my main screen then.
Yeah, just try sharing the whole screen instead of the window. I think that's the issue.
You see my main screen, so do you see yourselves?
Yep.
Switch here. So now
it still looks like not
it's moving.
No, now we're just seeing Discord. I think you presented just the Discord app.
Oh,
not your whole screen. Yeah.
Sorry about that.
These are 2020 problems, Lewis.
Yes, exactly. Okay, so I'm going to screen share. Oh, I know what I'm doing. Sorry, I totally my fault. I did that wrong.
There you go. Yeah. This is much better. Okay.
This now you see
now you...
slide, and now you
see
two slides, right? Now you see one slide.
Yeah, 2 slides.
And
there
this
you
moves.
Go. We got there.
Sorry about that. Thank you for letting me know. Thank you so much.
Thank
Please
you.
do stop me if anything else happens. I'm gonna rush through the beginning then. I have 4 sentences and I have a question, and I want to see which sentence is closest to the question. So the first thing I do is count how many words overlap, and the first one wins. This is lexical search, and it's terrible because, as you can imagine, if I have sentences that look a lot more like my question, in terms that they overlap in a lot more words, but are wrong, then that the lexical search doesn't take care of that. For example, where in the world is my cup of coffee is lexically the closest sentence to where is the World Cup, but that's not the answer. So we need something much more, something that takes care of semantics, that understands the sentence and is able to tell even if the word doesn't have, if the sentence doesn't have the same words, if the meaning of the word is the same. So that's where semantic search comes in. And for semantic search, there's something called embeddings, which is the bread and butter of a lot of these models, but in particular of embeddings of semantic search. So let me tell you, if you haven't seen an embedding, let me show you what an embedding is in a very simple scenario. So let's say that I've managed to put words in a plane. So I have the words soccer, basketball, tennis, castle, house, motorcycle, car, strawberry, etc. And I'm going to ask you a quiz, and I have the chat right here. So I want to ask the audience a quiz. The quiz is, where would you put the word apple? And here are, for example, the coordinates of each word, horizontal and vertical coordinate. And I'm going to give you 3 options: A, B, or C. So audience, where would you put the word apple? In A, in B, or in C? I see someone saying C. Very well. Yep, everybody's correct. I see a lot of C's. I would also put it in C. And why would I put it in C? Because, well, the point of embeddings is that similar words are close by and different words hopefully are far away. So that's it. We have, and so the coordinates for apple could be 5, 5, for example. Could be a lot of things. Something else that happens with embeddings is the following. Check this out. Where would you put the word Rabat here? So we have Croatia, Morocco, Zagreb, and Rabat, which are the capitals, right? So the question is, what coordinates would you put for Rabat? A, B, or C? I'm ready for answers in the chat. Who votes for A, who votes for B, and who votes for C? Let's see. I see C again. C, B, B. Ooh, that's a close call. So B is not bad because it's close to Morocco, right? Rabat should be close to Morocco, but actually I'm gonna go for C. And the reason is that these embeddings have sometimes a very particular interesting property, which is the parallelogram rule. And it just basically kind of captures analogies, right? Like Zagreb is to Croatia what Rabat is to Morocco, or Croatia is to Morocco what Zagreb is to Rabat, right? So this in the same way that from walking from the word Croatia to the word Zagreb is the same as walking from the word Morocco to the word Rabat. So this capture analogies, and it also captures some kind of like small mathematical equations, like Rabat equals Morocco plus Zagreb minus Croatia. Why? Because, well, it's sort of like the computer starts understanding what things mean. So Rabat, let's say the computer understands that it's Morocco and capital, and Morocco, it appears as sort of Morocco and country, and Zagreb appears as Croatia and capital, and Croatia appears as Croatia and country. So if I do this math and I subtract, then what happens? Well, country and country cancel each other, and Croatia cancel each other, and I'm left with Morocco and capital, which is exactly what I have on the right? And you can see that this math works out in the coordinates. If I were to add things coordinate-wise, this equation holds. So embeddings are just very useful things because they basically take words and put them into numbers in a way that makes sense. See, words that are similar appear with similar numbers, and words that are far away, different, appear with far away numbers. Now here we have a very, very simple one with 4 words or a few words and 2 numbers per word. But in reality, we want lots and lots and lots of numbers for every word, and we want every word in the dictionary. The embedding that one of the embeddings we have Cohere has 4,096 entries for each word. And this is basically a very good understanding of each word. But even more than word embeddings, we have sentence embeddings, right? So a sentence embedding actually takes each sentence and turns it into 4,096 numbers. And in the same way as before, similar sentences are close by, and different sentences are far away, and a lot more stuff happens, right? So this is the bread and butter of everything. This is embeddings. I was playing around in this lab where you can actually see the numbers. So I'm gonna show you the first 10 numbers of a bunch of sentences, and so it's 4,096, but I'm showing you the first 10, and we're just shading it to not appear as numbers, but the shading is in the value. You see it at the right. So notice that these sentences are all kind of similar, but in particular this sentence, show me a list of ground transportation at Boston Airport, and this one, show me Boston ground transportation, and this one, what ground transportation is available in Boston, are pretty much the same sentence, right? And notice that the embedding captured it. It said, you know what, I'm going to give you pretty similar numbers for those 3 sentences, even though the words are different, but it captured that these 3 sentences are very similar. So now that we have embeddings, then, and by the way, I have the chat in front of me, so if you have any questions, feel free to send them here, and I'll address them immediately, or right after. How to search. So now let me show you how do we use embeddings to search, and use embeddings to search. Like once you have a bunch of numbers to deal with, then it's much easier to deal with numbers than to deal with sentences, because you just do some basic math, right? So the way to do it is nearest neighbors. So let's say that we have our embedding. I'm gonna put it as 2-dimensional. So I'm gonna pretend that it's two numbers per sentence, when in reality there's 4,096. But in order to visualize it, let's do 2. And so let's say these are all your sentences. And now you have a question, a query. The query is, where is the World Cup? So you locate this sentence in the embedding, and then you simply just find which one is the closest sentence, the closest answer to that query. So see, having an embedding makes searching really, really easy, because then you get, the World Cup is in Qatar. Of course, there's difficulties and there's many things, many technicalities that happen, and Nils will tell you more about it in his talk. But just I'm going to show you a small example. I was playing with the notebook, and I put these 8 sentences here. And so there's 4 questions and 4 answers. And these are the 4 answers. The bear lives in the wood, the World Cup's in Qatar, the sky is blue, and an apple is a fruit. And let's do a basic search. The search is, where is the World Cup? And what happened is that the embedding put it right here. And so that's the answer. And just to show you that the 8 sentences appeared here in the embedding, and you can see that each question, the closest thing to each question is its own answer. So I hope if there's any questions, feel free. All right, so now let me tell you a bit about similarity. So similarity is actually something that comes out of embeddings pretty easily, and actually it's a number that tells us if 2 sentences are similar or not. So here are my 8 sentences, and I have calculated the similarity for each two and put it in this table. So you see like light colors are close to 1 and dark colors are closer to 0. So as you can see, each word obviously has a similarity of 1 with itself, each sentence. And the answer tends to be close to the sentence. So for example, what color is the sky? And the sky is blue, have a similarity of somewhere around 0.7. And that means they're close in the embedding, right? And if I look at what color is the sky and an apple is a fruit, then it's close to 0, that similarity. It's probably not 0, but something very small. So that tells us that our embedding is something like this. And now let me tell you how to get similarity from an embedding. Okay, so the way to get similarity from there's many ways to do it. You can look at distance, because we're talking about high dimensional spaces, where you can do like, you know, Pythagorean distance or taxi cab distance, anything you want. But we're actually going to use one that's pretty useful, which is cosine distance. So cosine similarity works exactly how you would imagine. We're going to look at the angle. We're going to say that the World Cup is in Qatar has a large similarity with where is the World Cup, because they're very similar. And where is the World Cup is far from the sky is blue, so they have small similarity. And so how do we find a large number between two close ones and a small number between the ones far away? Well, let's look at the angles, right? This angle between two close ones is a very small number, and this angle between two that are far away is a large number. And so we have to turn large number into small and vice versa. We're going to use the cosine. So this is the similarity between the World Cup is in Qatar and where's the World Cup is going to be cosine of the angle, and the similarity between where the World Cup and the sky is blue is cosine of the other angle. And why? The reason is because cosine is like this, and for a very small number, the cosine is a large number, whereas from a larger number, the cosine is pretty small. Let me know if there's any questions about that. I see some questions with Jacquard similarity work. Yes, I think probably Jacquard similarity will work. That's related to the dot product that is also related to the angle. Some questions like, how will it treat the similarity between the sentences the man bit the dog and the dog bit the man? So yeah, that's something that if it's a good embedding, it will take care of it, right? A very simple embedding will probably not know the difference, but a good embedding that takes care of sequentiality, embedding that actually looks at the sentence's meaning and not just the words in it. So if in a good embedding, like you would see a difference between the man bit the dog and the dog bit the man. It would have them far away, right? But for example, it would have the man bit the dog very close to the man. Sorry, the dog bit the man very close to the man was bit by the dog, right? Yeah, any other questions? Okay. Yeah, Saibu says, does the word order in a sentence affect embeddings? Yeah, a good embedding definitely captures word order in a sentence. So some basic models already do, like a recurrent neural network already captures the order of the words. So an embedding that uses context, that uses transformers and attention will definitely capture the order of the words. So just some things, some openers for the next talk. Yeah, the nearest neighbors is a pretty good algorithm, but it's actually not that fast if you just do it by itself, right? Like if I want to find what is the closest thing, the closest sentence to where is the World Cup, I would have to calculate pretty much all the distances with every other sentence in the space. This take time, and I actually would have to calculate all the distances between all the sentences. So if I had, this is a square, right? If I had 8 sentences, it's 8 square distances, and if I had a k 1000 sentences, a million, and in general is n squared. We don't want to do this. We don't want to be calculating n squared distances, especially if the number of sentences is humongous. And so therefore there are some solutions to this. One is inverted file index, which is in some way you cluster them, you group them around, and you have idea of what's neighbor, what things are close to one, so you sort of only look there. Another one is hierarchical navigable small worlds, which is, you have a huge set of sentences. Instead, you take just a few of them and find neighbors there. Then you add some more, and you have sort of a hierarchy of data sets, and that sort of gives you an idea of how to search faster. So I'm gonna tell you, I'm gonna tell you a little bit about what the embedding means in a multilingual search model. So the way it is I made some sentences, and I hope my French is good. My Spanish is definitely, I'm sure about that one, but I'm sort of 80 to 90% sure that those are my correct in French. But I use the Cohere embed model to actually embed them, not the regular model, but the multilingual model. The regular model will have them far away, but the multilingual model actually does this. It puts them pretty close, and the bear sentences are here, the soccer ones are here, the apple ones are here, and the sky is blue ones are here. So as you can see, the bread and butter of the multilingual model is that it not only sends similar sentences to points that are close, but it sends similar sentences in a bunch of different languages to points that are close. And that's one of the amazing things about the multilingual model. But now I'm going to obviously there are some difficulties with embedding and similarity, right? It's better than lexical search, but just doing this, just doing an embedding and finding the closest sentence may not be that great. I now put this small data set and I plotted it in 2 dimensions, the embedding, and notice that there's 4 points that are very similar. This one over here is where's the World Cup, which is the query. This one over here is the World Cup is in Qatar. This one is the previous World Cup was in Russia, and this one is the World Cup is in the moon. And notice that the embedding says these are similar sentences, right? They're all not lexically, but semantically similar. And the closest one says the previous World Cup was in Russia, which is very close, but it's not the answer. So how do you tell that it's the answer, right? So there's a lot more work to do this, right? Not just distance, but there's a lot more fine-tuning this model to make it good for search, to make it actually answer the right answer and not something that just happens to be a similar sentence. And so the question is, how can we make search better? And the answer is, stay tuned to the next talk by Niels right after this. And with that, I finish. So if you have any questions, feel free to put them in the chat, and we're happy to answer them. Thank you.
Thank you so much for the talk. Do you have chat near you as
I
well?
do have a chat.
I see there is a lot of questions regarding the model itself.
Yes.
And I'm not sure that you answered for all of them.
I've answered a few of them, but let me see if I missed any. This word order, I answered the word order being replaced by the we treat the similarity between man beat the dog and dog beat the man. The embedding takes care of that. Is distance considered if the two embedding have the same cosine similarity to a query? That's a good question. If you have two questions that have the same cosine similarity, would you consider distance? I'm for no, but I don't know if Nielsen or answer, but no, I don't think you're going to have equal things because we're talking about a huge embedding with many dimensions. So I don't think that's the case, but I think when you get into actual search models, like you do different things to see what's the actual answer, right? If you have ties. Let's see. Will you please repeat the solutions of the neighbor's distance? I'm not sure what that means. The solution of the first slide, or?
I have it in my talk, like how to efficiently search in large vector spaces.
Okay, perfect. This is for this question or for the previous question? For the
neighboring search.
Yes. Okay, yeah, that was an opener to Neil's talk. The two solutions to the neighboring distance, which are IVF. Sorry, wrong acronym there, and HNSW. Niels will talk about them in detail. So I'll if you're interested in that, then definitely stay tuned for Niels' talk.
Still have one more question.
Is multilingual model based on translation, or there is a model for every language that index to the same database? I'm gonna let Niels answer that one.
Okay.
Is
So
do you want to answer now, Niels, or
let me
Yeah,
introduce Niels and we can start the talk.
sure?
Fine?
Yep.
Okay.
share my screen.
Yes, thank you so much, first of all, Lewis, for the talk. It was really, really useful, especially for non-tech people, I'm sure. And now we are ready to dive a little bit deeper. And yes, as you already heard, I'm inviting Niels to the stage to have a deep dive into semantic search. Niels, you are on the stage now. Let me check.
Like multilingual lexical search.
It's need a second to load.
Yeah.
Oh, it's still loading. Could you please start it again?
Sure. Can you see it?
Yes, great, we can.
Okay, great. So yeah, I wanted to do a bit deeper dive on multilingual and why multilingual semantic search is so much cooler than lexical search. First of all, it gives you actually useful search results, but also in terms of development, it's so much easier. It's like 10 times, 100 times easier to do multilingual semantic search than multilingual lexical search. So first mentioned, as mentioned, lexical search is terrible. Sadly, everywhere you find lexical search. So if you go on Wikipedia, which is amazing website, really big, really popular, but still search function on Wikipedia is terrible. So if I search for what is the capital of the United States on Wikipedia, first entry is about capital punishment in the United States because it contains the word capital, the United States is, the States is. So on a lexical level, as Lewis said, it's great, but from a user perspective, it's totally disappointing. So in fact, Washington, D.C. is not retrieved on the first site, so it's not among the top 20 results. And you have to click through to actually find the right page you're looking for. And if you don't know that Washington, D.C. is the capital of the United States, how would you know which article you should read to get this information? Probably you don't want to read about capital punishment if you search for this, but yeah, how do you find it then? And what's even worse than lexical search is multilingual lexical search. It's like one of the most painful things you can develop as an engineer because the process really, really challenging. So in English, so how does lexical search work? In English, you take the English text, you tokenize it on white spaces. You look at like all the spaces, and then you separate this into like 3 tokens: multilingual, lexical, and search. Then to deal with like plurals, you apply a stemmer. So you reduce it to like some word stem. And because lexical search has issues with stop words like is, the, and so on, you remove stop words. The issue is that tokenization on white spaces works for English, but it does not work for Chinese. So if you have a Chinese text, you cannot tokenize on white spaces. Also, stemming in other languages is like really different, and stop words in Chinese are completely different than stop words in English. So your actual architecture looks a lot more like this. So you have a document, you run some language identification where you try to identify, is it English, is it Spanish, is it Chinese? And then for each language, you have like an individual pipeline where you first tokenize. So you have some tokenizer for English, some tokenizer for Spanish, some tokenizer for Chinese. Then you need to stem it to reduce, like remove plurals and endings, like exciting to remove the ending. And then you have to run like some stop words and you have to pipe it to like individual indices. So You have an index with all your English documents. You have an index for example, Elasticsearch with all your Spanish documents, and an index for all the Chinese documents. And the more and more languages you have, if you have like 10, 20, 100 languages on your platform, in your system, you have like hundreds of these pipelines which you all need to take care of and manage. And then at query time, if someone enters a query, you again have to do like language identification, and you have to know, okay, is it an English query? I have to search the English index. Or is it a Chinese query, and I have to search the Chinese index? And language identification on a query sometimes might appear to be easy, but it's actually like really, really tough. So for example, there's some movies in German, so American movies where the title has been translated to German, but actually they did not translate it to like a German title, but like to another English title. So for this English title, you would actually want to search in the German index, because that's the English title in Germany for German movie. And so you have like all these types of problems that you do not really know what's the language of the query. Semantic search solved this. It makes it a lot easier, and also makes the search results much better. So first, on the quality, if you ask the same question, what's the capital of the United States, with semantic search on Wikipedia, first entry is about Washington, D.C. is the capital of the United States. So that's first, you have like perfect search results. So you have perfect search results here. So how does it work? So Lewis already covered it. You have these vector spaces where you encode all the documents, and then you encode the query, and you find the nearest neighbor of these queries. How does it work a bit more in detail? So what you have like these queries and documents which you send to a transformer network like BERT. You do some pooling operation to give you a vector. And then you use some combination, some distance measure like cosine similarity, dot product, or so on to get a score. And in multilingual search, the nice thing is that you can map things independent of the language to the same point in the vector space, similar to what Lewis showed. And this makes the multilingual semantic search architecture so much easier. So you take the document query, you pass it to an embedding model, you get some vector, you get the vector in the vector database. That's all you need to do. It works for 100 and more languages. Doesn't matter if you pipe in like a Chinese text, French text, German text, Arabic text, Russian text. You don't have to care about what's the language. You don't have to do any tokenization. You don't have to do any stemming. Don't have to know what are stop words in China. You don't have like all these independent indices. You can pipe anything completely mixed in the same database, and you can search on it. And what's even more crazy for me is cross-lingual search. So because everything is a vector, you can search across languages. So you can take this Arabic text, which I'm sadly not able to read, but it's in Arabic, the question, what's the capital of the United States? If you search with keyword search like Elasticsearch on the English Wikipedia, obviously you do not find any entries. However, if you do this and you search with this with semantic search, you get the first entry about Washington, D.C. is the capital of the United States. If your document collection contains Chinese documents or French documents or Russian documents about Washington, D.C., they will also be shown there. So independent of the language, you can find the relevant information. As Lewis said, search in large vector spaces can become computationally expensive. So here we see the query, and for us human, it's kind of easy and straightforward to say, okay, this is like the closest document, so that's what I want to put at the first top. But for computers, it's kind of challenging to really say from all these blue dots which one is the closest to the query. And here you can apply different approaches. First, most simple approach is brute force. So basically, for every document, you compare the distance or similarity to the query, and then you sort them in a like decreasing order, like highest distance to lowest distance, and say, okay, these are the top five documents with the lowest distance or highest similarity to the query. challenge here is, of course, query time grows linear with the number of vectors. So if you have like 1,000,000 vectors, it takes quite some time to find like these closest points. But if you have like 10,000 to 100,000, maybe sometimes like 1,000,000 vectors, it's still doable to use brute force. So as soon or as long as you don't scale to like crazy large quantities of vectors, brute force is still the way to go. Second option is to call IVF. Here the idea is you run clustering on the vector space, so you take all these vectors you have, you cluster them into cells, and then at query time you put the query into it, you check which cluster cell is the query, and then you look at the neighboring clusters and in the cluster itself to find the closest embeddings for this query. Third technology is HNSW, which is one of the most popular architectures, which is like a hierarchical graph. So in the first level, in the top level, you put only really few embeddings, and you have like really long distances between the embeddings. And then at the query time, you first check in the first level of the query at the start point what's like the closest neighbor, and then you propagate to the next level. Here you pre-computed all the closest neighbors, and you can then navigate to like or check the neighbors of every point to see if they are closer to the start point. And then once you have found the closest point in this level that's closest to the query, to the starting point, you go to the next level and next level. So in the top level you have like really sparse vectors and you do big jumps, and the deeper you go in the graph, the more fine-grained the search gets. Luckily, you don't have to take care about this and implement this yourself. So for small data sets up to like 100,000 embeddings, use brute force with PyTorch or TensorFlow or NumPy. This is like a totally perfect solution, especially for a hackathon. If your data sets gets larger and larger, like 100,000 or 1,000,000 or even more, there are like different libraries you can use, like Phase and HNSW implementing these methods. I can highly recommend to use HNSW, it's really nice. There are different open source vector databases like Milvus, Cohere, and VV8 that are easy to spin up and to use. There are managed solutions like Pinecone and also VV8, Milvus, Cohere, where you don't have to take care of the servers and where they run it on their server themselves. Interesting aspect in multilingual search is language bias. So language bias defines the preference of a certain language combination. So for example, if I search in Arabic, what's the capital of the United States? What languages should the results have? Do I prefer like Arabic results over other results? Do I prefer Arabic results over English results or Chinese results? What if there's a result in a different language that's better, but it's a different language? Should it be like higher in the rank or should it be lower in the rank? And this is like kind of like the language bias. So how much do I prefer my own language, the language of the query, compared to other languages? And depending on the model, you can have like a stronger language bias or weaker language bias. So for example, in the top left, we see a model with a really strong language bias where we have all Russian text in the left part of the vector space and English text in the right part of the vector space, while at the top down we see a model without a language bias where the text is like heavily mixed between the two languages. And there's a question, is language bias in an embedding model, is it good or bad? And sadly there's no good answer for that. So let's say you have a model with language bias, so if you search in Arabic, it will find documents of the same language in Arabic, for example, higher just because it's also in Arabic. But there might be better hits or answers in other languages. So maybe you are bilingual and there's another hit in English that's so much better for your search query. Sadly, because it's another language, it's ranked lower. So you could say, yeah, you want to have a model without language bias. However, if you have a model without language bias, which totally ignores the language the query, you can get the following behavior of the model. So for example, you search for the word wedding, and you do it like in an image search setup, and you find like a picture like this, like a woman in a white dress and a man in a black suit, white skin, like the typical American, Western European picture of a wedding. If you search for wedding in Hindi, and the model does not know about the language, so it does not have like any bias in terms of the language. So here the Hindi word for wedding and the English word for wedding, it represents the same vector, and so it will fetch the same picture. So if you search in Hindi for wedding, you get the same picture. Even such, probably if you search in Hindi, you're more interested in wedding pictures from India. So how does a typical Indian wedding look like, which is not like a picture like this. Similar with things like who's the president. So if you ask this, you might want to have like know about the US president. However, if you ask in French, qui est le président? So if you ask in French, who's the president? You might be more interested in the French president and not in the US American president. So language filtering, that's a point probably Amr is going to talk about that. Users have preference for certain languages. So for example, I can understand German and English. If I search something, give me any results in German and English, I'm totally fine and happy to read it. But if you show me results in Chinese, sadly not really able to read it. Sadly, machine translation in Chinese is not perfect yet. So one option, if you have like a really mixed language corpus where you have like, let's say you take all Wikipedia, or you have like articles from Wikipedia across many languages. So one way how you can fix these preferences is you can run language identification on the documents. And then in the VectorDB, you can add like a language tag. Say this is from the English Wikipedia, that's from the German Wikipedia, that's from the French Wikipedia. And then you can filter queries. You say, okay, this is my query. Oh, show me only results in German and English, or show me results in Arabic and Chinese, or show me only results in French. So here you can do filtering based on the language preference you have for search results. And Amara will show more details in the next talk. So the Cohere multilingual embedding model can be accessed quite easily. So first you sign up with our website, you get an API key. So you post your API key here. Then you can define your text as mentioned, can be any language. The model supports more than 100 languages, so it will be tough to find a language that is not supported. You call co-embed, you say the model is multilingual, and then you get your embeddings. One important aspect which is confusing with embeddings, always confusing, here you have to use dot product if you compare two vectors. Don't use cosine similarity. So which metric to use always depends a bit on the model. Sometimes you have to use dot product, sometimes you have to use cosine similarity. Sometimes it doesn't matter and you can use both. But if you use the wrong metric to compare embeddings, performance extremely suffers. So if you use the multilingual model with cosine similarity, you will get really bad search results. And if you just do a switch and use dot product, which is also the more efficient method to compare vectors, you get way better results. So just to keep this in mind, if you follow some tutorials sadly show how to use cosine similarity. So really keep this in mind, make sure you use dot product. If you have questions on this during the hackathon, reach out, ask on Discord, is this the right metric to compare two embeddings? Yeah, that's so much from my side.
Yeah, thank you so much. I see that we had just the questions on chat, and Louis was kindly answering for them during the talk. And also, I see that somebody is asking, is the Cohere API a multilingual embedding model? So yes, it's Cohere's like a model, so you can use it during the hackathon together with all Cohere's products. And I see one more question. Hi, how can we deal with long text? Is in this case the whole meaning of the text will not be stringed?
Yeah, so that's a good question. So semantic search doesn't work for long text. So you cannot take a long text and encode it to a single vector. That's sadly mathematically impossible. What you need to do is instead chunk the text. So you take the text, you create like paragraphs, for example, take 100 words, and then you encode these 100 words individually. So you go from a long text of like 1,000 words, chunk it to like 10 paragraphs of 100 words each, and then encode these paragraphs individually, and then you do retrieval on the paragraph level, and then it tells you, okay, from this document, paragraph, I don't know, 18 is relevant to the query. And this is also super nice in terms of like a user interface for search, because then you can show the snippet. You not only say, okay, that's the document, but also here's the paragraph where I think it's relevant for the search query.
One more question in the chat. But do you see the chat as well?
Yeah, I can see the chat
Great.
as well.
So you see this question.
Yeah,
cool.
I can pick up the next question. So question is, can dimensional reduction help in vector database indexing and querying? What's the disadvantage of using it? So dimensional reduction sadly gives like a really big drop in search quality. So right now the embedding model, the multilingual embedding model returns 768 dimensions. If you reduce it to few embeddings to save some space in the vector DB, you will lose a lot of search quality. We're currently working on this to provide like a solution that's like really small and efficient, but still can keep most of the search quality. And we're planning to release this early next year. But right now, you shouldn't use any dimensional reduction. So if size becomes an issue, you can use binarization. So for example, Face supports support for product quantization, where you can reduce embeddings to a binary format. But yeah, this is only relevant if you really have like 100 millions of embeddings. And if you run into this problem during the hackathon, feel free to reach out, and then we can help you how to binarize embeddings.
Great, thank you. And yeah, by the way, you may just join Cohere Discord channel, and there is a lot of Cohere experts, and we also will have mentors from Cohere side on our Discord. So just feel free to ask them the question you are interested in, especially regarding the new model. And people say thank you in the chat, so thank you, Nick, so much for this talk. And I want to invite the next speaker for today, which is Amar Kite. Please confirm that you're in the channel and you can hear us. We'll have very interesting topic with Amar, which is the movie search and recommendation system, which can be really useful for your projects. And I'm very happy that you're here now. Could you please turn on your camera? Fine. And now you're live. People can see you as well.
Should I start the presentation now, or
yes,
wait
sure.
for 3 p.m.?
No, you may start it now. You may start it now with short introduction, okay, and then go to presentation.
Okay. Okay, sure. Let me first share my screen. Can you see my screen now? Amazing. So, hi everyone. My name is Amr Qaid. I'm a machine learning engineer here at Cohere. And today I'm gonna talk about our multilingual model, show you how can you use it, and have like a notebook walkthrough. And then I'll show you like some of the demos I have built with our model, and how you can build something similar or even cooler than this. So to start with, here's today's agenda, as I told you. And I'll start with an overview about our model. So as you may know, we released our multilingual model this week. But what is basically a multilingual text understanding model? This model basically understands the text in multiple languages. And say like you have like a list of like text in different languages, you send them to the model, and the model return numerical representation that encapsulate the semantic meaning of your text. And basically this enables advanced language understanding capabilities where you can use it for search, like searching by the meaning or categorizing your text. And this is useful for multilingual semantic search and also cross-lingual zero-shot classification. I'm sure Nils and my colleagues covered these in their presentation. So let's dig more deeply into how you can use the model. And here you have, you just need like to import Cohere, have your text prepared in a list, and then you call code.embed with your text, and then you'll get the embeddings easily. And it is very simple. You don't need like to write like hundreds of codes, just 5 lines of code, and you have your embeddings. But let's go to a notebook walkthrough to show you this in action. And later I'll share this notebook with you. It is an interactive notebook, and you can use it for your apps and demos. So basically here I just like install like the packages that I'm going to use and do some of the imports. And then here you need like to add like your Cohere API and initialize the Cohere client to be able to access the multilingual model. And here is like a small helper function that help you get the embeddings. And here you can easily choose like the multilingual model to be the model you want to use for the embeddings. And here I'm using UMAP. It is basically like a general purpose manifold learning and dimensionality reduction. And it is useful for visualization, as you'll see in the notebook. And this is also like a helper function to generate the charts, like the embedding chart. So you can see like the text embedded on the embedding space. And basically I have here like a data set with like simple text, one saying hello from Cohere and translated into a lot of different languages, Arabic, German, French, etc. And also like Cohere provides the best multilingual models in the world. And I just put them here in a data frame. And now I'm gonna call my get embeddings method and send like the text, all the text here to get the embeddings for each text. And then I'll use like the UMAP to reduce the dimensionality of the text of the embeddings that I have right now. And voila, here you can see like the embedding space and like the text embedded. You can see like here's the text like hello from Cohere, and like the similar sentences translated in other language close together in the embedding space here at this point. And the other sentence here as well, they are all close together, which is quite cool. And let's say like we have a new text and we want to embed it and see how where it is going to lie in the embedding space. So here I have hello from Cohere and I translated it into Japanese, and I added it into the data frame, and I got the embeddings for this new sentences, for this new sentence. And then I also did the dimensionality reduction of the embeddings. And let's see where the text was embedded. So pretty close to the text that is saying hello from Cohere as well, which is really powerful. And that is very cool. But like, let's dig deeply into semantic search and how you can actually search for like similar result to your query. So basically here I have this get similarity function which do like the dot product and return the scores and indices for the similar results to your query. And here I have like an input query text that you can modify and add your query here and play with it. And then I get the query embeddings for this text. And here I want to retrieve like the top 5 similar result to this query. This query is in Arabic. It's a ahlan wa sahlan, and it is basically saying hello and welcome. And it should be embedded close to the sentences that are saying hello from Cohere. So let's see what will happen. I get the embeddings, and then like I get the similar results after doing like semantic similarities. And then I'll do the dimensionality reduction, and let's look at the chart. And you can see here, this is like the orange one is the new query. The red ones are the ones that are similar to it, and the rest are the ones that are in the data set that were previously there. So I think it is very powerful, and I'm gonna share this notebook with you later, so you can play with it easily and take the code and adjust it to your idea. Now back to the presentation. Let me show you using the multilingual model, how can you build like some cool demos. To start with, this is like a movie engine recommendation that is built on top of our multilingual model. And this engine, basically you can like search for something like you want adventurous movie in the sea, and then you will get result similar to your query, and you can filter based on the language. So say you get the result in English, but like you really want result in Arabic or French or whatever language you prefer, you can filter it, and then you will get like similar result to your query. And how this can be done, as I told you, like first you need like to embed your data set. For this project, I used a data set called the movies dataset from Kaggle, which contain like around 45K movies from many countries. And I got like the text from these movies along with like a small overview, and then I embed all of the text with co-embed. Then I built this small app with an engine called like a framework called Streamlit, which is super easy to use for your app or demo. And then you basically perform a semantic similarity search between your query input, which you input here, and the embeddings you already have for your dataset for like the 45K movies. And then you get the result and retrieve it and show it. And I'll show you the demo in a second. And the second demo I have is like sentiment analysis. So sentiment analysis is very common, but unfortunately, most of the sentiment analysis just work with English because most of the data sets are in English. But using the multilingual, the Cohere multilingual model, you can easily perform zero-shot classification. In a way, you just need like to train a simple classifier on like your sentiment analysis English data set, and then using the embeddings and like the trained classifier to perform zero-shot classification on your input using your native language, Arabic, French, English, whatever language you want, and it will perform quite impressively on the text you input. And basically, these are the steps. You get like the embeddings for the sentiment analysis dataset you have. You train a simple classifier from sklearn or other frameworks, and then you just perform zero-shot classification for the text input after you get the embeddings for this text. And later you can use Streamlit or any other framework to show your demo. And also here are some of the data sets that I used and experiment with, and like you can reference to these links later. And also the code already on these repos. So co-movies are here, and also co-sentiment are here, and basically they are the same as what we did in the multilingual search notebook. And this is like the actual Streamlit app that you can use and try. It is public and it is open, so I am feeling happy right now. And you can see the classification for the text you have. Similarly with co-movies, you can search for whatever movies you really want. And one last thing I want to share before I end my presentation, there is also this sandbox repo, the sandbox multilingual repo, which also performs semantic search, and like it is very well documented if you wanna check it out and use it for your project. And with that, I can conclude my presentation. Thank you all for listening, and if you have any question, let me know.
Thank you so much for the presentation. People, thank you a lot in the chat as I see. And yes, we have questions, and let me just read it to you now. Please explain a little bit about zero-shot classification. I hope I was right in the pronunciation.
Yeah, sure. So basically, what you need to do is like in the normal classification, it will only work for English if like your embeddings is not well presented for other languages. But since like here the embeddings are quite good for multiple languages, it is like you are classifying similar thing to what you trained on your English data. So like here, for example, like like imagine like your sentiment analysis dataset, say hello from Cohere, and the label is 1, for example. All the other embeddings that are all the other text that is similar to hello from Cohere will have similar embeddings, and the classifier will be able to label it as 1.
Thank you a lot. I see like people are really grateful for you for this talk, especially in the chat. And there is one more, but I see it's like more general question about Cohere API itself. How Cohere API can I use for helping me write my blog? Maybe you can give us few use cases for the best models for this, and also maybe how it can be integrated with multilingual text understanding model.
So if I understand correctly, the question is generating a blog post using Cohere model?
Yes, probably, yeah.
Yeah, so there is a you need to distinguish between like Cohere generation models and also Cohere embeddings or like text understanding models. Right now, the multilingual model is only a text understanding models, which means it just provide embeddings for you, and it can generate text in other languages for you now. Compared with like our English generation models, which you can easily generate blog post, but it will be unfortunately in English for now. And for this, you can go to our Cohere playground, and you'll see like generate here, and there is actually a presets for you that you can check it out. So if you press on blog post, you can provide a prompt for the model. So I want you like to generate introductory paragraph for a blog post about something, and then like you give the title, the audience, the tone of voice, etc. You give it some few short examples, and then it will generate the first paragraph for your text here. So how to get started with rock climbing, and if you press generate, it will generate the first paragraph for you.
Great, thank you. One more question, which is more funny, but I need to ask it. Can the Cohere API model understand sarcasm?
I think so, in a sense, yeah. I haven't actually tried it by myself, but I think some of my colleagues tried it. So I'd say probably yes, but like let me double check.
Okay, great. And as also one more technical question. When working on a web app and loading the models from Cohere, how long does it take for them to load on location host? For example, the model from PyTorch would take ages to load.
So like uh, for using Cohere, you don't need like to load the models or anything. You just like call the model with the API, as I showed you here. Just like this line of code.embed text, and then you just specify the model. So no need like to set up PyTorch or TensorFlow or worry about any of the models. You just like call an API. So like it is an HTTP request, like you are calling the servers, and these servers we have host like the models for you, and like they are ready. Once you hit it, you'll get the result quickly and easily. It doesn't take time at all.
Amazing. So it's super easy to use, probably. As we heard from
Yeah.
from feedback of people who was building it, because it's not the first hackathon of Cohere, it's probably seventh episode of Cohere hackathon. So people are really like this, like easy to use model, because it's really good to get started with. Thank you so much for this presentation, and I see that people
Yeah,
really
my pleasure.
enjoyed it. And
Yeah.
yeah, do you have something to say in the final?
Yeah, I think I'm gonna share like the slides, the notebook, and also the repos, so people can benefit from the code and reuse it, so they can focus on their ideas. And I really look for seeing a lot of cool demos and ideas, and I'm excited to try them. So good luck with all with like the teams, and surprise us.
They will definitely surprise. Thank you so much. And I see that, yeah, they was asking a lot about sharing the links and presentation. And we
Yeah,
would
sure.
love to share it on our Discord with you right after they Cohere. So we will contact.
Sure.
Yeah, great. And now I want to say huge thanks to all the speakers it was today. And now it's time for me to tell you that, guys, start building. And if you need any additional help, you see, no, here the links for all the channels, and also you may contact Nasty. And now, the moment that you was waiting for, Nasty will come back to us with amazing presentation, how to use our Discord and how to work with our website for you to make it extremely easy and to not ask us additional questions. So now she will show you everything you need to know about our lablab.ai server on Discord and lablab.ai website. Nasty, just confirm that you're here and you can hear as well.
Yes, hello, Alicia. I'm here. I can hear you. I will share with you my screen. Can you please confirm? Can you see Discord now?
Yes, I'm right.
Okay, and lablab.ai? Great. Hello everyone, my name is Nasty. I'm back to you. I hope it's better connection. Today I'm gonna show you our LabLab.ai platform and Discord community. So let's start. Here you see our main event page for Semantic Search Hackathon. Once you are enrolled for the event, you will see something like a dashboard. So we will go here. Yes. And here you will have your dashboard. I will open it here. Yes. And you have a choice to create a new team, or you, of course, may join one team who are looking for a member. So yeah, you can find them and asking team members to join you for the team. So, but we want to create a new team. For example, you feel that you are really good, you have an idea, and you want to be a team leader. So let's try to create a new team. Test, description, test. Okay, and we will see what happened now. Yeah. And we have here new team. You see, here we have option that I'm a team leader. I can delete this team if I want, of course. And it's very important to get a voice Discord channel. You have to invite one member to your team, then at least two members you will have with your team, and then the voice dedicated voice channel on Discord um, will appear on our platform. So, for example, I want to invite someone. I click here. Teammates, yeah, and here you have a link to your team. What? And some technical issues with our internet, but okay. When you click here at teammates, you will have like your link. So you copy this link and go to our Discord. Remember to connect your Discord to LabLab.ai. And first of all, you will see section welcome and section with our rules, our team introduction. I will shortly show you our team. Here is our mentor teams. For this event, you can tag Erwin, you can tag Omar, Skander, and Gonzalo. They will help you. Erwin and Omar are really good with technical questions, so feel free to ask them. And also, you can ask Laszlo and Fabian. This is our developers on LabLab, so they also can help you with any technical issues relating to the hackathon or for example, to Discord platform. And also feel free to tag me or Olesia. So we most of all can help you with business question or organizational questions. And also I can redirect your request to our mentors. Here you will find LabLab General channel. At this channel you can write everything you want, some questions, some ideas. Feel free to write it here. And then we scroll down a little bit, section welcome, introduce yourself channel. At this channel, we can get know each other, so you may introduce yourself, write here about your background, your experience, And after that, you will find happening now. It's our hackathon channel, Semantic Search AI Hackathon. Someone, I saw that someone asked, where is OpenAI Hackathon? It's our previous hackathon. We're finishing with this hackathon, so we still have this channel. You don't need to use it. Please don't write here anything. This is your main channel, general channel for this hackathon, Semantic Search AI Hackathon. And here you may also tag something, write the questions, tag me, feel free to tag me, so then I can notice and quickly jump and help you. As you see, today I already wrote to you and proposed to you to create some teams. So when we are scrolling a little bit down, and we will find looking for a team section. Again, here you will find also OpenAI Hackathon. Please don't write here anything. It's another one hackathon. Here you will find your dedicated channel for this hackathon. And in this channel, you can find your team, or also as you are a team leader, for example, you may paste your link to your group and invite people join your team. Or if you don't want to create a new team, feel free, write something like, hello, I am looking for a team. But it's not enough. My suggestion to write a little bit more about yourself. For example, hello, I am looking for a team. I'm a programmer, I'm a developer, I have a great idea, I can help you with organizational, with design, and something like that. Then people can notice it and invite you to the team. And here I created a thread for programmers and developers. So if you are a programmer or developers, you may also write here, like for example, here we have good examples. Hi, I'm Python and web developer working on problem solving with API. So here you may write your background regarding programmer experience. So people also who are looking for members, who are looking for programmers, especially, you may go here, and also you can paste the link to your team channels and invite people join your team. But yes, remember that the dedicated voice channel on Discord, you will have this opportunity to create it after you will have minimum 2 members with your team. So if you are a solo team, you want to have, for example, yeah, we have some examples when people don't want to have a team. I want to be a solo. You're welcome. Okay, feel free. But then you don't need a dedicated channel on Discord because you are solo. If you need help with mentor, okay, no problem. You may go, for example, to AI general question section or to our general semantic search section and use attack mentor here. And write, for example, hello, I need help. Hello, I want to discuss an idea with you. So then you may meet your mentor directly and text with him or, directly. Or, for example, also you can talk. You can call him. Yes, then we have a section questions. Here you will find if you have some questions regarding hackathon, how I can create a team, so you will find the answer here. And also AI, we have AI general, programming questions, I need help, bugs, Discord questions. Also feel free, write there something. Our developers, me and our mentors will notice it and we will try to help you. This is the next one, our section knowledge. Here you will find the useful articles, AI news, so you also may share with your ideas, feel free to do it with your videos. And my lovely one channel with memes. Yes, and here below you will find community voice. So yes, Open Voice 1 and Open Voice 2, when we will have together an interview, I will ask you jump to the Open Voice channel 1 or Open Voice channel 2. So then we can add you to the stage. This channel you will not see. And I also want to introduce you how it looks like from admin page, because here you see for mentors. So I suggest you use calling for a help on your laplab.ai page. When you use it, here we have, I will show you something like that, that we can notice that some of team, for example, team alpha needs your help. Mentor will see it and he can quickly jump to your voice channel and help you. So it's really good option to get help quickly, because when you text in general channel, we may notice it not so fast as you want. So yeah, it's the best way to contact with mentors. Use calling for a help button on lablab.ai. And also, I will show you, some of you asked already why I don't have a text channel. We had it previously, text and voice channel as well, but Discord has some limits, so we decided leave only voice channel. But don't worry, when you click here, you have something like open chat. So this is the same. You see? Oh, someone tagged me and asked for help. This is the same option if you will have separate text channels. So don't worry, just click to the voice channel and you will find also chat. I think that's it. Here also, please check announcement. I will announce all our updates. I will write it here. And yeah, I hope you will have a great time on our platform. Again, feel free to ask us for help. And it's better to ask us by tagging us in our dedicated channels. Thank you so much, and I wish you good luck and wish you good time spending with us. Bye.
Thank you so much, Nasty, for your talk. We really enjoyed it, and I hope now you have last questions regarding Discord. I know you will answer it otherwise, but still, we are happy that we can talk to you today and to explain all the new stuff on the platform, and even like not the new, but still for you to better understand how our communication may works more efficient, and it might be much more easier for us to like discuss some ideas with us. And guys, thank you so much for being on this stream. I saw there was like really a lot of you during today's kickoff, and I'm really happy to have you here. And just to finalize and give you time to form your teams and to work in your projects, wish you the best of luck and have fun during this hackathon, because it's probably the most important part of this hack is to really have fun during your journey here. And we are here for you, me, Nasty, and plenty of mentors that will help you during this hackathon. Feel free to reach us out, and thank you for being with us. See you later, probably. See you on the Discord.
Bye.